In this video, we want to learn how we can find the value of definite integrals involving absolute value. Let us start with this example. Integral from -2 to 3 of absolute of x minus 1 dx. For finding the value of definite integrals involving absolute value, first we have to try to get rid of the absolute value. The reason is that for absolute value, we don't have any formula for antiderivative or integral of these type of functions. So the idea is to get rid of the absolute first and then start integrating the function and finding the value of definite integral. But how we can get rid of the absolute value? For that, always we have to set the expression inside the absolute equal to 0. So in this case, we have to set x minus 1 equal to 0. So first we set x minus 1 equal to 0 and then we solve this for x. In this case, x equals 1. Then if this number, if the solution of the equation is in the region of the integral, it is between lower bound and upper bound, in this case 1 is between -2 to 3. We split the given integral in this way. We write this integral as integral from -2 to 1 plus integral 1 to 3. But why we do this? Now, if you pay attention, we have intervals, we have two intervals, -2 to 1 and 1 to 3. In these intervals, now we can find the sign of this expression. This lower bound and upper bound show the value of range of x. If x is between 1 to 3, consider x as a number between 1 to 3, like 2. If x is between 1 to 3, x minus 1 is a positive expression or a negative expression. If you think carefully, because x is between 1 to 3, x minus 1 is a positive expression because x is greater than 1. X is something between 1 to 3. So, absolute value of x minus 1, when x is in this region 1 to 3, x minus 1 is positive. And so absolute of x minus 1 is x minus 1. And now, if we look at this integral, we don't have absolute value anymore. In this way, we get rid of absolute value. What about the other integral? When x is between -2 to 1, let's say x is 0, or x is -1, or -1.5, any number between -2 to 1, x minus 1 is a negative expression. So please pay attention. In this integral, x is between -2 to 1. For numbers that are between -2 to 1, x minus 1 is less than 0. Or it can be 0. When an expression is negative, what is the role of absolute? The role of the absolute is to make it positive. How the absolute makes the expression that is negative positive? By multiplying the expression by a negative. So, in this region, the absolute of x minus 1 is equal to negative of x minus 1. And don't forget to write dx. So, now if you look at these two integrals, in both of them, we don't have any absolute anymore. And now we can calculate these integrals easily. So let's review the process again. Always, we have to set this expression equal to 0. Then we get a number. Then we split the given integral in that number, as we did here. -2 to 1, 1 to 3. Usually, in one of these regions, the expression is positive, so we write the expression itself. In this case, this is the one that expression is itself. And in the other interval, which is this case, this expression, absolute of this expression is equal to negative of that expression. Now we can calculate these two integrals. For the first integral, don't forget we have a negative. What is the integral of x? X to the 2 over 2 minus, what is the integral of 1? X from negative 2 to 1. For the other integral of x is x to the 2 over 2 minus 1. Integral of 1 is x from 1 to 3. Now we have to just substitute the upper bound and lower bound, subtract them from each other, and we can calculate the value of this definite integral. So we have negative. If we plug in 1, the upper bound in this expression, don't forget we have a negative that we wrote here. If we plug in 1, which is the upper bound of the integral, then we have 1/2 minus 1. Minus, because we have another minus here, then this would be plus. Now we have to plug in negative 2 in this expression. If we plug in negative 2, then we have negative 2 to the 2, which is 4 over 2, minus negative 2 would be plus 2. Now let's go to the next substitution that we have to do here. First we plug in 3. Then we have 3 to the 2, or 9 over 2, minus 3. Minus, plug in 1, then we have 1/2 minus 1. The first bracket from the left, 1/2 minus 1 is negative 1/2. We have a negative outside, so this would be 1/2. The next bracket is 4 over 2, 2 plus 2, 4, so plus 4. 9 over 2 minus 3, 9 over 2 minus 6 over 2, because we can do a common denominator. 9 over 2 minus 6 over 2 would be 3 over 2. And 1/2 minus 1 is negative 1/2. We have a negative outside, so plus 1/2. So in total we have 1/2 plus 3 over 2 plus 1 over 2. In total would be 4 plus 3 plus 1 plus 1 is 5 over 2. If we do a common denominator, it is 8 over 2 plus 5 over 2, and this equals 13 over 2. So the value of this definite integral is 13 over 2. So this equals to 13 over 2. Let me explain something here, then we go to the next question. When we set this expression equal to 0, we get an answer from the equation. Maybe 2 solutions or 3 solutions. But what if this answer is not in this region? Then, if the answer is not in that region, it makes the solution easier. For example, suppose we have this integral from 2 to 5 of absolute of x minus 1 dx. When we set this expression equal to 0, we get x equal 1. But 1 is not in this region. So in this case, it means that this expression is either always positive or always negative. And if you pay attention here, when x is from 2 to 5, x is a number between 2 to 5. X minus 1 is positive because x is greater than 2. Let's say it's 3, 3.5, 4, 4.5. So x minus 1 is positive. And when the expression is positive, so we have only one case. This integral equals integral from 2 to 5 of x minus 1 dx. And simply we can calculate this integral right away. So we don't have two separate cases. We have only in this case one case. And in this particular question which I showed you here, the expression is always positive. And just we copy this expression without multiplying by a negative. This is the case when the solution is not between lower bound and the upper bound of the integral. But the question is more interesting when the solution is between the lower bound and the upper bound of the integral. Now let's move to the next question. Here we have integral from 0 to pi of absolute of cosine of x dx. Similar to the previous question, we set cosine of x equal to 0. If you remember from trigonometry, when cosine is equal to 0, when x equals pi over 2. Let me remind you from unit circle. At 0 cosine value, the value of cosine, which is the x-axis, is 1. When we go toward pi over 2, at this point, when the angle is pi over 2, or 90 degrees, the cosine is equal to 0. And when we continue toward pi, which is here, this angle is pi, the cosine value is -1. And if you remember, in the first quadrant, cosine is positive. From 0 to pi over 2, cosine is positive. From pi over 2 to pi, cosine is negative. Let's back to our question. By setting cosine equal to 0, we got x equals pi over 2. And because pi over 2 is between 0 to pi, so we divide this integral to 0 to pi over 2 and pi over 2 to pi. From 0 to pi over 2, which is the first quadrant, cosine, sine, and all trigonometric functions are positive. So absolute of cosine of x is cosine of x dx. But from pi over 2 to pi, cosine of x is negative. In the second quadrant, cosine is negative. And because cosine is negative, the role of the absolute is to make it positive. How it makes the cosine of x, which is negative, positive? The absolute multiplies the cosine by negative. So in the first integral, we have cosine of x dx. So in the second integral, we have negative cosine x dx. Attention, cosine of x is negative. When we multiply it by a negative, now it is a positive expression. Now our job is to simply calculate this integral. This equals to, what is integral of cosine? Sine of x from 0 to pi over 2. And the integral of negative cosine is negative sine of x from pi over 2 to pi. We substitute. If we substitute the upper bound, we have sine of pi over 2. But sine of pi over 2 is 1. If we plug in 0 for x, sine of 0 is 0, so 1 minus 0. In the second integral, we have negative sine of x. We have to plug in pi, but sine of pi is 0. So we have negative 0 or 0. So by substituting pi here, negative sine of pi is 0. Minus, now we have to plug in pi over 2. If we plug in pi over 2, sine of pi over 2 is 1. But don't forget we have a negative here. So we have minus 1. Upper bound makes this expression 0. Lower bound makes this expression -1. Don't forget the negative between them. So we have this. 1 minus 0 is 1. In the second bracket, we have 0 plus 1 is 1. 1 plus 1 is 2. So this integral equals to. And let me show you the interpretation for our answer that we got here. The graph of absolute of cosine of x. If you remember, graph of cosine of x is something like this. It starts from 1, then it goes to 0, then it goes to -1, and it continues. But here we have absolute of cosine of x. So this part which is below the x-axis would reflect in the x-axis and it becomes positive. So graph of absolute of cosine of x is this. The positive part remains positive. This part which was below the x-axis, you should reflect it and it would be something like this. Now we want to find the integral from 0 to pi. 0 is here. Here is pi over 2 and pi is exactly here. The area of these two regions is 1 plus 1 is 2. So the area of the first region is 1. The area of this region is 1. 1 plus 1 is 2. Now look at this example. What is the integral from negative 1 to 2 of absolute of e to the x minus 1? Immediately we set the expression inside the absolute equal to 0. From this e to the x is 1, and by solving this, what is e to the what power is 1? 0. Any number other than 0 to the 0 is 1. So from this equation x is 0. Another way to find x from this equation is to take ln from both sides, and then x equals ln of 1. ln of 1 is 0, so x is 0. Now we split the integral from negative 1 to 0 and from 0 to 2. From negative 1 to 0, e to the x minus 1 is negative. From 0 to 2, e to the x minus 1 is positive. So in the first region, we have negative of e to the x minus 1 dx. In the second part, we have e to the x minus 1 dx. For example, why from 0 to 2 this expression is positive? Consider a random number between 0 to 2, like 1. If you plug in 1 in that expression, then we have e to the 1 minus 1. We know that e is 2.7 almost. 2.7 minus 1 is 1.7, and it is positive. And because in this region, from 0 to 2, it is positive, so we can guess that in the other region, which is from negative 1 to 0, it should be negative. And if you want, you can check it by substituting a number in the expression. Let me show you how. From negative 1 to 0, you can consider x as, for example, negative 1. You can consider negative 1/2, numbers like that. If, for example, we choose negative 1/2, then we have e to the negative 1/2 minus 1. E to the negative 1/2 is radical e, or a square root of e. E to the negative 1/2 is basically 1 over a square root of e minus 1. And this is similar to 1 over radical 2 point something. 1 over radical 2 point something is a fraction, and it's smaller than 1. So we know that whatever the value of this expression is, it is less than 1. So let's say it is 0. For example, 7. Minus 1, this is negative. In this way, you can check that the expression is negative, and because the expression is negative, we multiply it by a negative to make it positive. Now we are ready to integrate and find the value of the integral. For the first integral, don't forget you have a negative outside. Integral of e to the x is e to the x, and integral of negative 1 is negative x. If you like, we can multiply the negative in the bracket, and then substitution would be a little easier. So let me do it here. So I am going to multiply negative in the bracket. If I multiply negative in the bracket, we have negative e to the x plus x. So we have negative e to the x plus x from negative 1 to 0. For the other integral, we have e to the x minus x. Integral of e to the x is e to the x. Integral of negative 1 is negative x, and from 0 to 2. Now is the time to do the substitution. If we plug in 0, we have negative e to the 0, and negative e to the 0 is negative 1. So we have negative e to the 0 plus basically 0 minus, now plug in negative 1. If we plug in negative 1, then we have negative e to the negative 1 minus 1. This is for the first integral. For the second integral, we plug in 2. We have e to the 2 minus 2. Then we plug in, don't forget you have a negative here, minus, plug in 0. E to the 0 minus 0. Here we have a negative 1 in the first bracket. Then we have plus e to the negative 1 and plus 1. Minus times minus 1 is plus 1. Then we have e to the 2 minus 2. E to the 0 is 1, so minus 1. Negative 1 with plus 1 cancels. At the end, we have e to the 2 plus e to the negative 1 minus 3. And this is the value of this integral. Let's move to the next example here. What is integral from 0 to pi of absolute of sine of x plus cosine of x dx? Similar to the previous questions, we have to set the expression inside of the absolute equal to 0, and we have to solve it for x. To solve this equation, we have two trigonometric functions, sine and cosine. In this form, it's a little hard to find the value of x. So we prefer to make it in terms of only one trigonometric function. And to do that, immediately you can divide both sides by, for example, cosine of x. But the standard way is to write this equation in the form of negative cosine of x. Now, because we have in one side sine, in the other side cosine, and basically we have to work with two trigonometric function, we divide both sides of this equation by cosine of x. If we divide left side by cosine of x, sine x over cosine x would be tangent x. And if we divide the right side by cosine of x, negative cosine over cosine would be negative 1. Now we have only one trigonometric function, tangent x. And now we have to figure out where tangent is negative 1. If we look again at unit circle, in first quadrant, tangent is positive. In the third quadrant also, tangent is positive. And in the second and the fourth quadrant, the tangent is negative. So we have to look for angle in the fourth quadrant or second quadrant. If you remember, when tangent is 1, from famous triangles, if you remember, the angle that is tangent is 1 is pi over 4. So the reference angle is pi over 4. But we want the tangent to be negative, so we look for angle in the second and the fourth quadrant. In this particular case, we have to look for quadrant 2 only, because our region, please attention to the integral, the region of the integral, the lower bound and upper bound shows 0 to pi. So we look for an angle between 0 to pi. So we look for an angle in second quadrant. And in the second quadrant, if the reference angle is pi over 4, if this angle is pi over 4, the actual angle, that is tangent is negative 1, would be pi minus pi over 4, which would be equal to 3 pi over 4. So this integral can be written as 0 to pi 3 pi over 4 plus 3 pi over 4 to pi. Now we have to figure out in each of these integrals what we have to write. We have to write either this expression or negative of this expression. But how we can figure out that? It's very simple. As usual, we try a number in this region. In the first region, which is 0 to 3 pi over 4, is from this point up to here. For example, you can consider pi over 2, which lies in this region. If you plug in pi over 2, sine of pi over 2 is 1, cosine of pi over 2 is 0, so this expression is positive. So, because the expression is positive, absolute of this expression would be equals to itself, because it's already positive. We don't need to change anything for this integral. You can check other angles. For example, you can plug in 0, you can plug in pi over 4, pi over 6, pi over 3, but maybe pi over 2 or 0 is easier, which I tried pi over 2 and I got a positive result, so I copied same expression. Because in the first region, in the first interval, the expression is positive, we can guess that probably in the other region, which is from 3 pi over 4 to pi, from this point to this point in this region, this expression should be negative. But to make sure, for example, we can try exactly this point. Attention, if you try this point, it doesn't work. you will get 0 and you cannot figure out is it positive or negative. And so for this interval from 3 pi over 4 to pi, we try pi. If we plug in pi, x equals pi, then we have sine of pi plus cosine of pi. Sine of pi is 0, cosine of pi is negative 1. So, as we expected, the expression is negative in this region. And because the expression is negative, the absolute should make it positive. How? By multiplying the expression by a negative. So, for this interval, we have negative of sine of x plus cosine x dx. And from this point, the question is really simple. Just integrate, substitute. But be careful, substitution is not really easy. You need to be careful about signs and everything. What is the integral of sine of x? In the first integral we have sine. Integral of sine is negative cosine. What is integral of cosine? Sine of x. From 0 to 3 pi over 4. In the other integral we have negative sine. Integral of negative sine is cosine. Integral of negative cosine is negative sine. From 3 pi over 4 to pi. Let's do the substitution. If we plug in 3 pi over 4, negative cosine of 3 pi over 4, in the second quadrant cosine is negative. So cosine of 3 pi over 4 would be negative of negative radical 2 over 2 or 1 over radical 2. It's up to you which form do you prefer to write. Remember, cosine of or sine of pi over 4 is 1 over radical 2 or 1 over the square root of 2. But in the second quadrant, cosine is negative. So cosine of 3 pi over 4 is negative of 1 over radical 2. Now we have to plug in 3 pi over 4 in the sine. Sine of 3 pi over 4 is 1 over radical 2. In the second quadrant, sine is positive. And sine of 3 pi over 4 is like sine of pi over 4. And sine of pi over 4 is 1 over radical 2. Now we plug in 0. Minus, if we plug in 0, we have negative cosine of 0. But cosine of 0 is 1. So minus negative 1 and sine of 0 is 0. Now we want to plug in pi here and here. Cosine of pi is negative 1. Sine of pi is 0. Minus, now we plug in 3 pi over 4. Cosine of 3 pi over 4 minus 1 over radical 2 minus sine of 3 pi over 4 minus radical 2. If you look at the first bracket, we have 1 over radical 2 plus 1 over radical 2. So it equals to 2 over radical 2. Then we have a plus 1. Then we have a minus 1. And in the last bracket, we have negative 1 over radical 2. Minus 1 over radical 2 would be minus 2 over radical 2. You have a negative outside, so plus 2 over radical 2. And finally, this equals to 4 over radical 2. And this is the answer of this integral. Attention, if you like, you can write 4 over radical 2 in the form of, if you rationalize this, if you multiply top and bottom by radical 2, this equals to 4 radical 2. Radical 2 times radical 2 is 2. The 2 from the top with the 2 from the bottom cancels, and this equals to 2 radical 2. If you like, you can write your answer as 2 radical 2. And this is the answer of this definite integral involving absolute value. I hope by watching this video, you have learned how to find the value of definite integrals involving absolute value. If you liked this video, please subscribe to my channel and see you in the next videos.